surface quality. Additionally, another system, the MRMR proposed by Jakubek and Laubser in 2000, have also accounted for the influence of rock strength anisotropy and its orientation. Further, there has not been any other attempt to incorporate anisotropy in any rock mass classification system. Concluding on this, a system should take into account both inherent anisotropy of intact rock and also the anisotropy of the structure, which is practically dominated by the spacing of the anisotropy planes. Therefore, a system cannot be based on a chart. The aim of the proposed system is to be able to differentiate two anisotropic rock masses with different degrees of structural anisotropy. And that is in the case even if the strength anisotropy of the intact rock is similar. I will move on to present the anisotropic rock mass rating classification system. The system follows the general rock mass rating approach proposed by Bieniawski in 1989. It incorporates two new rating categories, practically the strength anisotropy index and the degree of structural anisotropy. It addresses orientation dependence of the rock quality designation due to anisotropy, and it is also accounting for stress effect. Of course, the system is used in the modified Hooke-Brown failure criterion for a rock mass. Now, the parameters which are used are 6 parameters: the strength anisotropy index, the uniaxial compressive strength of intact rock, the degree of structural anisotropy, which is practically defined by the spacing of the anisotropy planes, the corrected rock quality designation, the condition of anisotropy surfaces, and the groundwater conditions. The first parameter, which is the strength anisotropy index, is based on the classification proposed earlier. So practically, 5 categories of strength anisotropy index are proposed and a value of the ARMR rating is given. So the lowest value will be for a high intact anisotropy rock, and the highest value, equal to 20, will be for an isotropic rock, like for example the case of the marble that we discussed earlier. In the uniaxial compressive strength of intact rock, we are following the IRSRM classification of strength, and of course the categories proposed by the RMR rating. So in this case we can see that we have the highest rating, which is equal to 15 for the high strength rocks, and the lowest strength rocks will give the lowest value of ARMR. Another degree is the structural anisotropy. This accounts for the principal structure. The principal structure of anisotropy planes, which is practically defined by the spacing. So the spacing, we have a value of 20 for the case of spacing larger than 1.2 meters, while for the spacing lower than 40 millimeters we have a value of 5. The corrected rock quality designation is calculated by omitting from the calculations the anisotropy plane. We can see that the corrected rock quality designation can be rated by between 2 and 15. By correcting the rock quality designation, we reduce the directions dependence of RQD that can arise from poor sampling, with higher values when drilled parallel to anisotropy planes or lower values when drilled perpendicular to anisotropy. The condition of anisotropy surfaces, it is referring to the principal structures, so the principal anisotropy planes, and it follows the RMR rating. So practically, for very rough surfaces, we have the highest rating value, and for low conditions like soft couch, field anisotropy planes, we have the lowest value. Finally, the groundwater conditions, we have, similar to the RMR rating, from completely dry to flowing, similar approach with a range between 0 and 15. In terms of stress adjustment, we are practically correcting the total rating according to the in situ stress. The in situ stress conditions are characterized as low, intermediate, and high based on Martin et al. From the ratio of sigma 1 over sigma c. So when we have low in situ stresses, there is no change in rating. When we have intermediate in situ stress, we move one cell towards the left in the classification of the compressive anisotropy index. When we have a high in situ stress, which is practically when the ratio of sigma 1 over sigma c is larger than 0.4, we move two cells towards the left in the rating of compressive index. This is in order to take into account the stress effect. Now, in terms of total rating, we can see that we have 5 categories, similar to the rock mass rating. And we have a description for each case, from isotropic, slightly anisotropic rock mass, moderately anisotropic rock mass, highly anisotropic, and very highly anisotropic to sheared rock mass. The table that presents the ARMR classification is shown in this slide, and we can see the different rating parameters and also the final classes predicted by the classification. The system will be applied in specific cases from rock masses which behave in a different manner. We are going to apply it in a slate rock mass, in a quartz schist rock mass in USA, in a shale rock mass in Australia, in a gneiss rock mass in Greece, and the calcic schist rock mass in Italy. The first rock mass in Jiangxi province is a foliated slate in a quarry. It has a well-developed slaty structure, and practically it has a strength anisotropy degree of 2.6. Based on the RMR classification, we define the uniaxial compressive strength, the spacing of an isentropic structure, the corrected RQD, the condition of surfaces and groundwater, and we can see that the final rating results in a moderately anisotropic rock mass, 50 to 54, the total ARMR value. There is no stress adjustment because we are in unconfined conditions. The next case is a quartz schist rock mass in the United States, which is practically a former gold mine at a depth of 1,500 meters, which is going to be a world-class physics lab. The rock, if we see the outcrop in the mine, we see that it's a very good quality rock. When we see an intact rock sample, we see that it's a very intensely foliated quartz schist. In this graph, we can also see the variation of strength of the intact rock, which is pronounced. And this, as we see in the classification, we can see, based on ARMR, that we have a strength anisotropy degree of 1.87, and then this means practically slightly to moderately anisotropy of the intact rock, and in the total rating we see that we have 63 to 67, which practically gives a slightly anisotropic rock mass. In this case, we are adjusting due to stresses, and the final rating